Okay, so we are starting Chapter 2, Functions, Equations, and Graphs. So Section 2.1 is Relations and Functions. So what we're going to do is we're going to graph relations and we're going to identify functions. So first thing we're going to talk about is graphing relations. A relation is a set of ordered input and output values. You can write the relation as a set of ordered pairs. So for example, usually I use these braces, and if I had 0, 1, maybe 1, 2, and 2, 3, this would be a relation written as a set of ordered pairs. So the next part we want to graph each relation. So when you're graphing each relation, of course, remember that the first variable is your x variable, comma, your y variable. So remember that this right here is your x-axis. This is our y-axis. So if we want to graph this, so we have 1, 2, 3, 4. So this graph goes out to 5 here, 5. This would be -5, and down here would be -5. So when we're graphing, we have 0, 4. So we don't go right or left any. We go up 1, 2, 3, 4. And then I put a dot right there. So that would be 0, 4. So then for the next point, we have -2, and then 3. So to the left 1, 2, and up 1, 2, 3. And then we have -1, so left 1, up 1, 2, 3. It'll be right there. And then the next one we have is -2, so left 2 and up 2, -2, 2. And then we have +1, so right 1, up 1, 2, 3. So I just didn't write all the names there. So those are all the ordered pair values that we have. So why don't you guys, while I'm graphing this, you graph it on your paper, and then you can check your answers when you are finished. One 1.5 is a little bit harder, so it'd be in between 1 and 2. So this is what your graph of your relation would look like. So the next thing we want to talk about is the domain of a relation and the range of a relation. So the domain of a relation is the set of all inputs or x coordinates of the ordered pairs. So make sure you write that down. And then the range of a relation is the set of all outputs or y coordinates of ordered pairs. So make sure you write that down too. So when you're writing the domain and range, you always want to write it in order from least to greatest. So write in order from least to greatest. Just like in a number line, we go from the negatives to the positive. And then you also do not repeat numbers. So that means that you only write them once. We don't write them multiple times if we have multiple of the same values. So you can find the domain and range of a relation from a graph. For example, find the domain and range from each of these relations that we have graphed right here. So when you're writing the domain, usually we use these little curly brackets, and we would want to write now the values in order from least to greatest with no repeats. So we have to remember that your domain are all possible x values that you can have. So remember that your x values start here on your graph and they're going to go this way. So we're going to write the values going that way on our graph because that's our x values on our domain. Okay, so for this first one, what is the lowest x value that I have, which is right here? So that is an x value. We're not writing down the y value, it's just x because it's domain of -3. So that would be the first thing that I would write down. Then the next x value I have is here, which is an x value of 0. And then I'd go to this one, which is an x value of 2. And then the last one right here, which is an x value of 4. So again, notice that they're in order from least to greatest. I didn't have any repeating x values, so we're okay there. So now I want to go ahead and do the range. So remember, the range are all of the possible y values that I can have. So the range then is going to be going this way on my graph. So we start with the lower numbers to the higher numbers. So this is the lowest y value that I have. So again, I use these curly brackets. So the lowest y value is -3. The next one would be right here, which would be at a value of 1. The next one is here, which is a value of 2. And then this one right here, which would be a value of 4. So then you have -3, 1, 2, and 4. So why don't you take a second and pause the video and go ahead and see if you can do B. So while you're doing that, I'm going to write my answer, and then after you're done, click on pause so that you can check your answer with what we have here. So for this one, notice when I wrote the domain, I have -3, -1, and 1. And notice that I didn't write -1 3 times just because I know I have a dot here, I have 1 here, and 1 here. So I don't need to write the x values 3 times, I just write it once. Same thing for the x value of 1. I have an x value of 1 here and here, but I only write it once. And remember, in order from least to greatest with no repeats. So then if we do the range, the range values, remember, go this way on my graph. So I have a y value here of -4, then this one would be -2, and then I have a y value of 1, comma, I have a y value here of 3. And again, notice that I did not repeat the numbers. So -4, -2, 1, and 3 would be the range of this graph. So check to make sure you got that right. If you didn't, then pause it and I would correct your answer. Okay. So the next part we want to talk about is mapping diagrams. You can also use a mapping diagram which links the elements of the domain with corresponding elements of the range. So when you're doing this, you make an oval for the x values. And then step 2 is you make an oval for the y values. Step 3, you draw arrows from the domain, which remember is your x values, to the corresponding range, which is your y values. So basically, whatever x coordinate, you draw the arrow to the corresponding y coordinate, so to which one that you have as the ordered pair. So for example, mapping of the relation. So here we have our relation of ordered pairs. And so we made an oval for the x values here, and an oval for the y values, our range, here. Notice that the numbers are written in order from least to greatest. And if you look, you'll notice that we have the ordered pair -1, -2. So -1 goes to -2. And then we have 3 to 6, so 3 goes to 6, and then -5 to -10, and the last one, 3 to 2. So that one has 2 that it goes to. So again, just make sure that you remember it's in order from least to greatest with no repeats. So let's practice doing some of these mapping diagrams. So, for example, given these relations, we want to make the mapping diagram. So what you want to do is, again, first you make an oval for your x values, which is also called your domain. Or square, doesn't matter if it's really oval. And make one for your range. So I'm just going to make it more of a rectangle kind of. So then we write our ordered pairs. We want, first of all, our x values are our domains. We have 0, 1, and 2, which is already in order. So 0, 1, 2. And then over on the other side, we are going to write our range values, which are 2, 3, and 4, which are again in order. And then we want to pair them up with their corresponding partners. So 0 is paired up with 2 because of this coordinate right here. 1 is paired up with 3, and 2 is paired up with 4, so that would be your mapping diagram. So now what I want you to do is pause the video and see if you can do example B. Once you are done with example B, then hit play and you should see the answer up there. So -1 goes to 7, so that takes care of that point. 1 goes to 3, so that takes care of that point. 0 goes to -2.5, so that takes care of that point. 1 also goes to 7, and -1 also goes to 3. So this is what your mapping diagram should look like. Notice that the numbers are written in order from least to greatest with no repeats. So why do we do these mapping diagrams is the question. It's because we're concerned about things that are called functions. So you're asking yourself, what is a function? A function is a relation So it's a relation in which each element of the domain is paired with exactly one element of the range. So what that means and what we normally say is that for every input, which remembers means for every x value, there is and only one output or y value. So this is basically how we tell or determine whether or not something is a function. So for every x value, there is only one and only one output or y value. So basically what you are really looking for is repeating x values. So you're looking for repeating x values. So that's the big thing right there. So example, determine whether each relation is a function. So if we look at these and we want to determine their function, we would go ahead and look to see if for every x value there's only one y value. So how do you tell? You look for repeating x values. So if we look at this first mapping diagram, this 3, notice this 3 is being mapped to the 4 and to the 5. So this input value has 2 output values. Therefore, this cannot be a function. So no, or not a function. And why is that again? It's not a function because the input, -3, has 2 outputs. So x equals -3 has 2 output values. So why don't you see if you can do B and C really quickly. I'll give you a second to do that. So once you hit pause, and then when you hit play, we'll go over them together. So looking at B then here, we again look for repeating x values. So notice here that 2 goes to the 6, 3 goes to the 6, 4 goes to the 5, and 7 goes to the 8. So notice that none of the x values go to a second y value. So then this would be a function. So yes, function. And again, there's no repeating x values. Now you'll notice that some of the x values do go to the same y value, like 3 goes to 6 and 2 goes to 6, but that's okay because you're allowed to have 2 x values go to the same y value. You just can't have an x value go to 2 different y values, so that's why that's a function. And for C, if we look at this one, notice that I have 1 goes to 7, 0 goes to -3, 0 goes to 7, and then 1 goes to 10. Because of this number right here going to -3 and 7, this is not a function. And again, why is that? Because x equals 0 has 2 output values. So it goes to -3 and to 7. So let's go ahead and go back up to the 2 problems we mapped out before the 2 relations. So if we look at this first relation that we have right here, notice that this first relation, each x has only one y, so yes, this would be a function. And over here, notice that if we look at these x values here, goes to 2 output values. This x value has 2 output values, so this would not be a function. Okay. So the next thing that we need to do, so we can tell whether or not something's a function by looking at a mapping diagram. We can also tell whether or not something's a function by looking at the graph. So how do we tell if something's a function by looking at the graph? We use what's called the vertical line test, and I think I missed that down here. So the vertical line test is determining the graph as a function, and what do we do for that? It's if a vertical line passes through 2 or more points on a graph, then the relation is not a function. Sometimes, if you remember from algebra, you might have heard this being called the pencil test. And I'll explain why that is in just a second. So let's go ahead and look at some examples. So we're going to use the vertical line test to determine whether each graph represents a function. So the reason this is called the pencil test is because if you take your pencil and you go from left to right on your graph, if it passes in more than one place where it hits, or the graph has more than one place where it hits the pencil, then it is not a function. So let's say this line that's right here is our pencil. So as I move from left to right on my graph, if it hits more than one place on this pencil, then it is not a function. So you notice that it hits in many places. So if we look here, notice that it's hitting right here and right there. As we go across the line, it kind of changes depending on where our line is. So even as we keep moving, notice it's again going to be hitting here now and here. So because of that, this does not pass a vertical line test, so this would not be a function. So why don't you take a second to see if you can do the other two problems. So if you look at now this B, as we move our pencil across the paper from left to right, we're looking to see, does the graph hit our line in more than one place? So no, 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 no. So since it did not hit in more than one place on our pencil or on our line, we know that this graph is a function. So yes, function. So this passes the vertical line test, or again, sometimes we call it the pencil test. So over here, for C, we would do the same thing, and notice right when we get here, it's hitting at those two spots, so this point right here and this point right here. Since it hits in two places, I can say right then and there that this is not a function. And we can continue for this graph if we wanted to. So it passes here, it passes there, and again, it does not pass here because it hits those 2 points on that line. But we don't really need to go. If we see that it fails here, then we can just go ahead and stop. So if we go back to the first graphs that we did when we made our mapping diagram right here. So if we look at these graphs, I'm going to erase this a little bit. Let's see if these are functions. So again, how would we do that? We would use our vertical line and see if it hits in more than one place on our line. So no, 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 no. So this passes the vertical line test, so this is a function. And if we do the next graph and take a look at it, so if we go tracing through here, notice that it hits 3 points here and it hits 3 points there. So that means, again, we have repeating x values that we're hitting, so this is not a function. Okay, so let's go back to our other page. So now we're going to also talk about function notation. So we have used equations before when we talked about slope-intercept form and things like that. So let's just say we had the equation y equals 2x plus 7. So this should look familiar. This is slope-intercept form. 2 is my slope, 7 is my y-intercept, but we don't really need to talk about that right now. What's important is that we know that the x value is the input, and the y value is our output. And we know that the 2x plus 7, that kind of tells us what to do. So instead of using y values now, we're going to use what's called this function notation. So this function notation would be written, this equation would be then written like this in function notation. This is said f of x, is how we say that, is equal to 2x plus 7. So for this x value is still the input, and then when it goes inputted, you would put the x into this x value right here in your equation. So this right here is really the directions that tell us what to do. So these are the directions. And so then what is this f of x? This is really now our output. So it's just a new way of writing things. Instead of writing y equals, we're using this function notation. And the name for this function is the letter that's in front of the f of x that we have here, which in this case is f. So this is the name of the function. Sorry, that's hard to read. It just says it's the name of the function. So again, why do we use this function notation? Usually because as we get into upper level math, it's easier to then be able to tell when I plug something into my equation, what was the equation that I used. So for a certain x value, you get a certain y value. So if we take a look at this first example, it says find f of -3, f of 0, f of 1/3 for the following functions. So if we take a look at A here, we have f of x is equal to 5x plus 2. So we're going to be inputting stuff in for x, which would go there. Then the directions are 5x plus 2 tells us what to do, and f of that number is going to be our entire output. So in this case, if we wanted to do f of -3, I'm going to be inputting 3 into my equation, so I'd have 5, that's where I'm going to put my 3, plus 2, so this -3 goes right here, and now I just need to go ahead and simplify that. So when I simplify it, I get -15 plus 2, and then -13. So the way that we write this is f of -3 equals -13. So this is nice notation because then that tells me it's kind of like an ordered pair. So instead of writing it out as an ordered pair, we know that if I were to write this as ordered pair, my x value when it's -3, my y value would be -13. Now you don't need to write that for all of these problems. I just wrote it there so that you could see that that's your x value and this is your y value. So instead of saying y equals -13, like we used to write y equals -13, now we're writing f of -3 equals -13. It's just a different way of doing it. So let's go ahead and do the next one. So the next one, I'm going to write next to it because I'm going to run out of room. So let's do f of 0 over here. So for f of 0, we do the same thing. 5, we're going to input 0 here for x plus 2. So that's where the 0 goes, and then I got to simplify it. So 5 times 0 is 0, and then we have plus 2. So I know f of 0 is equal to a y value of 2, and that would be my answer. So that says y is 2, x is 0. So then the last one, we have a fraction, which is f of 1/3. So do the same thing. 5, we're going to input the 1/3 plus 2. So then I got to go ahead and simplify this. So 5 times 1/3 is going to give me 5/3 plus 2. And then you can get a common denominator here to add these together. Or, if you want to use your calculator, add them and hit the math fraction key, whatever helps you. So when I do that, I get 11 over 3, which we like to leave our answers as fractions. So f of 1/3 is equal to 11/3. And so this would be my answer. So when I have an x value of 1/3, my y value is 11/3. So why don't you go ahead and do B, C, and D, and when you're done with that, then you can check your answers because I'm going to go ahead and put them up here for you. So if we go ahead and take a look at our answers, for B, f of -3, when you plug it in, you get -10, so you can check your work there. F of 0 ends up being equal to -1, and f of 1/3 equals to -10/9. So make sure that you remember that it's right here, there's that negative that we have in front of our equation, so negative, and then x squared minus 1. So you're squaring your numbers, and then you still have the negative in front that you have to worry about. So if you got those wrong, make sure you correct them. For C and D, f of -3 should be 9, f of 0 is 0, and f of 1/3 is 1. So remember, when you take the absolute value of something, it's going to end up giving you positive answer, because the absolute value of something is the distance from 0 in a number line. And so if we look at D is a little bit harder because we have a fraction there. F of -3 should be 9/4. So you have to be careful here because if you plug this in your calculator, a lot of students get this wrong. You would have to make sure to put parentheses around everything that's in your denominator. So if I were to plug this into my calculator, the way that I would plug that in is I would do 9, and then I would hit the division key, and then parenthesis 1 minus parenthesis -3 close parentheses, and then I would hit the equal sign to give you a decimal, and then hit the math fraction key, and then you get 9/4. So same thing. So f of 0, 9/1 minus 0 is 9/1, which is just 9, and the more trickier one is f of 1/3. So again, put parentheses here if you do in your calculator. So 1 minus 1/3, if you get a common denominator, 1 would be 3/3. So 3 minus 1 gives you 2/3, and 9 divided by 2/3. Remember, when you divide a number by a fraction, so really if we had 9/1 divided by 2/3, the way that you divide that is you multiply by the reciprocal, which would be 3/2. So if I multiply by 3/2, I get 9 times 3 is 27, and 2 times 1 is 2, so that's where the 27/2 comes from. So make sure that you have all those notes down, and what we'll do is we'll just kind of look at it tomorrow and see what kind of questions that you have.